right, let's get started. Thanks for coming. We're going to talk about reactive programming APIs in Java 9. Let's talk a little bit about reactive programming. We'll then talk about the Java 8 Streams API, as we are familiar with in Java 8. What are some of the power and limitations of it? Why should we really look beyond Java's 8 Streams? And then we'll take a look at what's available in Java 9. Best time to ask questions is whenever you have the questions. I'm told that Chris here is very eager to throw a microphone at you. So do ask questions along the way so that we can, just kind of bounce that around if you want to. So absolutely, anytime is a great time for questions, comments. Just draw our attention, speak up, and then we'll be more than happy to listen to you. So let's talk about reactive programming just a little bit. I started talking about this maybe about, I can't remember, 8, 9, 10 years ago. And at that time, I would say, this is something that would be really exciting in the future. But it turns out, that future is now. If somebody's looking for a seat, you're most welcome to find a seat here. Otherwise, you can also go to room number 6. This talk is being transmitted in room number 6 as well. So what is reactive programming really? Well, reactive programming is a way of thinking. This is not really new at all. It's been around for a long time. Yet, in our field, we get really excited giving new names for things we already do. And this time around, we give terms like reactive programming and stuff like that. But this is a concept that's been around, but there's a reason why we are suddenly excited about it. If you really think about it, a lot of things have changed in the past about 10 to 15 years in our industry. Once upon a time, we created applications for employees to use, and then we made these employees available to the customers. Well, those employees who use the application, they're called as captive users, meaning nobody cares what they think about. But right now, we are giving applications for end users to use, so the applications we create have to be really responsive. It's got to be reliable, so the needs are very different. Secondly, also, the types of application we are building, the type of data we are communicating is very different. Every single one of us is carrying multiple devices with us. The other day, I patted my son, and several devices fell off him. I don't even know how many things he carries with him. It's kind of like that we carry multiple devices. I mean, forget about, Apple Watches. I'm talking about earrings, nose rings, and tongue rings, all internet-enabled and transmitting data continuously, which means we live in a day of big data, high-volume data, high-frequency data. We want to be able to deal with it. Let's talk about a few applications that are actually reactive. One of my favorite examples is a very old application. I would even argue that's probably one of the best applications humans have ever created, Microsoft Excel. If you really think about Excel, the minute you change a cell in Excel, all the other cells that depend on it immediately changes. And then all the other cells that depend on those cells immediately change, and then it propagates through. That's being reactive right there. So reactive applications are applications that respond to stimuli very quickly. Other applications we live in today, if you really think about the types of applications we create today compared to what we did previously, well, most of us have spent time on creating what are called CRUD applications. CRUD applications are applications where we create data, read data, update data, and occasionally delete data. At some point, we ask the question, is everything CRUD? But if you really think about it, we have applications that monitor social media. Are we talking about a product? Are you talking about a company? Are you talking about a service? And is it a problem you're raising? Are you giving a compliment about it? There are applications that want to constantly look at it. There are applications that want to monitor a flight as the flight is moving through. And as a result, you want to be able to constantly take those feed and process it. We're not really dealing with reading from a database per se. So what we did in the past was we had a database, and we read the data, we'll call it as a function, and then we wrote back the data back to a database. Now we are looking at a fairly different way of computing where we take the data, but we pass the data through a function, and in turn, then we take the data, and that produces another set of data, and then we do this computation where the data flows through a sequence of computations, wherein we call this as data flow computing. And as the data flows through systems, we want to be able to handle this continuously, and it's a very different way of thinking we are really trying to do in terms of meeting the demands of the modern applications. I'll give you another example of what I think is a really good reactive application. And in fact, it took me a while to really realize it. I travel almost 100% of the time. which means I'm almost always away from my home. And I constantly communicate with my family using electronic documents. My wife and I share quite a number of Google documents, and we log on to Google, we exchange whatever that we need to exchange almost constantly through it. But I was in one of those trips, and one morning I wake up, and all of a sudden I realized that when I went to Google Docs, I noticed that Google Docs told me that she was actually editing the document exactly at the same time. And immediately I scrolled down to exactly where she was editing, and I put my cursor exactly where her cursor was, and I started changing the text that she was changing. With this, I found out I could be thousands of miles away and still find the way to annoy the spouse. This, to me, is a brilliant use of reactive programming, because you're able to instantly communicate with somebody who is thousands of miles away, and for her to say, get out of my document now, was absolutely precious. So, and then I realized I actually communicate with a lot of people around the world constantly. Sometimes 20, 30 people get onto a document, we edit it across the world, and we immediately get a feedback as to what we are editing. That's an example of reactive applications as well. Well, talking about this, why can't we just be happy with the Streams API in Java 8? I want to compare and contrast just a little bit about Java 8 streams versus the so-called reactive streams. Well, the reactive streams were created as a way to answer some of the concerns I talked about. Well, in case of Java 8, there are some similarities and there are quickly some differences as well, and I want to highlight some of those similarities and differences. The first similarity is we have a pipeline of data processing in the case of Java 8. Well, it turns out in reactive streams also, we have a pipeline. So that's, first of all, the good news is there's common between them. Java 8 stream is lazy evaluation, and it turns out that reactive streams also are lazy evaluation as well. So you have the benefit of laziness in both of those. And of course, in this case, the data flows, and here also data flows as well, and I'll say simply also. We'll see what that means in a few minutes. So we have these similarities between Java 8 streams and reactive streams. But unfortunately, the similarity ends very quickly soon after that. When it comes to Java 8 streams, it only flows data. So I'm going to say only right here, and I said also over there. But the question really is, how does Java 8 stream deal with error? I can describe that with two English words, and that is called good luck. And essentially, you can't really deal with errors when it comes to Java 8 streams. Remember what the Java 8 stream says. You're in a pipeline, and right in the middle of the pipeline, something goes wrong. What does it say? It says, blow up the pipeline. That's not a very smart thing to do. It's like somebody is saying, I'm driving on the street, and my car got a flat tire. What should I do? Your answer is blow up the freeway. That's not a good idea. The good answer is take the nearest exit safely and deal with it downstream. In fact, I never thought I would give an example. Usually I give examples from real life, but this was quite in reverse. I always give this example in my classes, but I had to live through this a few weeks ago, and I was pretty shocked and surprised about it. I was in Boston speaking at the Java user group one night, and the very next morning I had a flight to Montreal. So I get up in the morning and I said to myself, I'm a world traveler. I don't need to really leave early for the airport. I'm just fine. So I started driving. It had snowed pretty much the previous night. The road was covered with snow, so I didn't have a way to look at what's on the street. So as I started driving, this was 4 in the morning, and my flight was about 6:30 in the morning. So I started driving to the airport. As I was driving to the airport, I heard a noise, and within seconds, my tire was completely flat on the right side. So I get down and take a look at it. Well, there's no way to really fix it right now. And I called the towing service to get for help, and they said, oh, we'll be with you within 2.5 hours. That's not going to work because I had a flight to catch within the next 2.5 hours. So I sat there thinking about what should I do, and immediately I thought of the examples I normally give, deal with it downstream. So I got in the car quietly, buckled my seatbelt, and I started driving all the way to the airport with a flat tire. And you should have seen the people's face when I got into the airport. They were like, what happened to you? And I'm like, oh, just a flat tire. And I gave them the keys. This is when you are so happy it's a rental car. And then, of course, I quietly walked over and took the flight. The point really is that you deal with it downstream. So in that regard, what reactive streams provide you is 3 channels of communication. What they have is what's called a data channel. They also have what's called an error channel where the error is going to go through. And then they also have one more thing, which is called the complete channel, where a complete signal is going to be sent if there is no more signal to be received. So there are these three channels of communication that you really get into when it comes to your reactive streams. And that's one distinction between a stream in Java versus reactive streams itself, is the data stream will have the data. And if something were to go wrong, error channel will have the error, but the data channel will close up at this point. There'll be no more data through it. And a complete channel will have a complete signal. At that point, there will be no more data coming through. So that's one big difference between the two. Moving a little forward, when it comes to the Streams API in Java 8, it is really sequential versus parallel. So we know that we can do parallel streams, we can do sequential streams as well. The clear distinction in reactive streams, on the other hand, is it is actually synchronous versus asynchronous in the way it is going to be dealing with things. That's another difference that you are dealing with in terms of the differences between these two kinds of streams. And maybe one more thing we could say here is that when it comes to the Java 8 streams, you're pushing data all the way through, and there is no real concept of back pressures. So data, simply just flows. That's all it does. Whereas in the case of reactive streams, you also have back pressure, so you can deal with a difference in data flow rates, and there's no real power to deal with the difference in data flow rate when it comes to streams in general. And lastly, I will mention one probable difference we need to really be careful about between these two is that when it comes to the Java 8 streams, you have a single pipeline, if you will. There are no forks, there are no branches that are permitted in a Java 8 streams, whereas in the case of a reactive stream, you can also have multiple subscribers as well. So these are some of the differences between these two stream-based processing idea. So the concept of dealing with streams is very natural for a lot of things we do, and even though the stream-based API exists in Java, there's clearly a need for going a little bit beyond it. And that's one of the things that the reactive streams really provide for us. So having said this, let's talk a little bit about this. It's really coming down to data flow computing, and we talked about the channel of communication, but one of the beautiful features of reactive streams is that it's a non-blocking operation where you can have back pressures. So there are some rules of engagement. The first rule of engagement is that you cannot force a publisher to be any faster or slower than they can publish the data. So if I'm going to be sending data, I'm going to be sending data at the rate I'm sending. Don't ask me to go slower. Don't ask me to go faster. Similarly, the receiver of the data, the subscriber, is going to work at the rate at which the subscriber can work. You cannot tell the subscriber go slower or go faster, and so they can go at their own pace. So then how do you really deal with the difference in speed? What if the publisher is publishing data faster than the subscriber can handle it? That's where the concept of back pressure really comes in. In the case of back pressure, you can say there are several options you can consider. You can say, as you transmit the data, maybe I'll put that into a buffer. And that makes sense when there is a period when you are going to be a little slow, and then you can get back to your normal operation, you can catch up. Or you could simply say, if I don't really have ability to handle this, throw away the data, and you can drop the data. That also makes sense in some situations where you're really interested in processing the data as it's available, but not really a backlog of data. That's not your interest in this particular application. Then this becomes really useful. So there are some rules we can follow related to that. Given this, the Reactive Stream API has some really good benefits, and this idea has been around for quite a number of years. You can read through what is called the Reactive Stream Manifesto, and the Reactive Stream Manifesto is really focused on talking about, how do we really, what are the concerns of building reactive applications? The Reactive Stream Manifesto talks about 4 pillars of this paradigm. One of them is that it is elastic. So what does it really mean to be elastic? Well, when you're building applications, there's a limitation to how much you can run on a single box. Suppose I have a processor with, let's say, 256 cores on it. You may say, gosh, that's really a lot of cores, isn't it? Well, yes, but unfortunately, if I'm doing computation-intensive job on this, then I'm limited to 256 threads on that box because the limitation is the number of cores, not the number of memory, unfortunately. So as a result, if I really want to improve the performance and scale, I would have to really put this on a cluster. But thankfully, this is one thing the world has done really well over the past about 10 years, is in 2007 timeframe, cloud computing was really becoming popular. Now we can say that we have really learned a lot of things from cloud computing, and one of them is elasticity. Servers can come to life when the demand goes up. Servers can go away when the demand goes away. So as a result, we can be elastic in providing the scale that we need. Second is message-driven. So what is message-driven really? Well, one of the things I want to emphasize is, especially in the world we live in, it makes no sense to share a database. I'm going to say that having a centralized database and distributed transaction is really so 20th century. So in other words, we don't want to be communicating between applications by having databases that are common. So one of the things I normally recommend is do not expose your database. Instead, export your data. So this is something that I think we should really follow is we should not expose your database. Instead, you want to really be able to export the data. And as a result, when you're exporting this data through the systems, how do you really communicate this data across multiple services, multiple functions that need to use this? Well, some kind of messaging is really needed. Once again, message-driven is not new for us. It's been around for a long time, and yet this is one of the second pillars of this paradigm. The third is responsiveness. Now think about this for a minute. The applications you quit using are the applications that are not very responsive, that are very slow. Remember the day you learned about infinite scrolling. You've been visiting the site, it's a little slow, but that day when you went to the site, it was a pretty wicked fast, and you're thinking, gosh, that was really fast, what's going on? And then you scroll up, and then you notice there's no bottom on this page. And before you could really think about it, the page fills up with more data. And this is a nice way for you to really give pieces of data incrementally. And that is because you really want to make the application responsive at this point. Responsiveness is extremely important because when an application is very slow, we quit using the applications. We live in a world of instant gratification now. We are in devices. You're using an application, it's slow. You don't even realize you've moved on to other things like tweeting and checking your Facebook messages. And somebody says, hey, what did you see? You're like, what do you mean, what did I see? Oh, that application. Oh, it still sucks. It's pretty slow. The point really is that we want responsiveness extremely important. This is like you walking into a store on a Saturday morning and you see the clerk who is busy in the store. What do you normally do? You probably look around for a few minutes, you look at the wall, you look at the ceiling, and you walk away because there was no response. On the other hand, you walk into the store and the clerk who is busy looks at you and says, I'll be with you shortly. You probably waited for a good 10 minutes. And the reason is you felt suddenly important, even though you know you're not. And that's one of the beautiful things about responsiveness is it brings loyalty, it hooks on clients to our applications, users to our applications. Well, the last thing to really consider is resilience. And resilience is extremely important because we want applications to fail gracefully. Well, we cannot build applications that don't fail, but what you don't want is applications that fail miserably. When applications fail gracefully, we can recover as a user and continue to use the application. So gracefulness in recovery is important. This is one of the things that reactive programming emphasizes is that errors are first-class citizens, and as a result, we can deal with errors like they are some form of data rather than treating them as something alien as exceptions, and that's one of the things we get out of it. So given these Reactive Streams Manifesto, a group of companies got together and they really wanted to think about how to build reactive applications. And quickly they found out that they all were creating things in bits and pieces, and the problem really is the developers end up suffering if there is no standard to bring them together, so they really wanted to standardize on it. So as a result, what they created is a Reactive Stream API, And this Reactive Stream API, so turned out, had 4 different interfaces as part of it. The first one is a publisher. And the publisher is an interface that says that it would emit data at whatever rate it wants to emit. So a job of a publisher is to emit data, and the publisher is going to be the source of the data that's going to send the data through. That's the job of the publisher. Of course, the other end of this is a subscriber, and the subscriber's job is to subscribe to a feed of data and then process it the way they want to process it. But one of the really nice things about this particular model is, right in between these two, you have what are called processors, and the processor actually wears 2 different hats at the same time. A processor sits right in the middle, and the processor is subscribing to a stream of data, but it also emits the data on this side, and in the process, it can do transformation of the data. So it wears the 2 hats, like I said. It's a subscriber to the publisher up here, out in the upstream, but it's a publisher to the subscribers downstream. So it is both a publisher and a subscriber. So this becomes a publisher plus a subscriber, and it normally sits in between a publisher and a subscriber. And finally, what you have is a subscription, where the subscription is going to be the context or the session that's between a subscriber and a publisher. As an example, I might subscribe to a magazine. If I have multiple children at my home, I might actually subscribe to the same magazine multiple times, because when you receive a magazine at home, asking children to share it may be an act of war sometimes, depending on how the children feel about it. I might have 2 copies of the same magazine arriving at my home, so I have 2 subscriptions as a subscriber, even though I'm a single subscriber. So this is really a subscription that you may get from the publisher for that particular subscriber. Well, those basically are what you had in the Reactive Stream API. While this existed, a bit of a concern was among developers asking the question, hey, what is the solution for this from the JDK? What is JDK going to provide for us as far as reactive programming is concerned? Well, the problem is that the world has moved on quite rapidly by the time, and you don't want to come in and say, oh yeah, this is a great idea, we want to create a standard. Well, that's a little too late, and it's a little, it's not the best thing to do to really disrupt what has been done already. But at the same time, you do want to have a standard moving forward, so that was kind of the little bit of a confusion as to where to go. So Java 9 decided to introduce a Reactive Stream API as well, as a way to say that, this is really an important idea. We do want to promote a standard API for the world to follow. So what did they do? They created a Reactive Stream API for themselves, and you can imagine what the very first interface they created. That interface was called as Publisher. And the second interface they created, that was called as Processor. The third they created was called as Subscriber. And the fourth one is called a Subscription. You know where this is going. So they pretty much said, you know what, we want the standard, but you all did really good job. What you did is really wonderful. We'll make that a standard. So essentially, moving forward, all these different organizations decided that they would follow the Java 9 standard, but the Java 9 standard was actually created by these working groups in terms of what they have been doing. So it is a standard moving forward. At this time, it's more of a blessing to say, yep, this is a great idea. We approve of this. This is where we want to move forward. And moving forward from here on, Java will maintain the standard for this particular progress. But as of now, it's really a de facto standard that's been brought over as a standard within the Java 9 implementation. So that begs the question, what is it that we have available in Java? And the short answer for that is almost nothing. And the reason I say almost nothing is we do have the interface, we have it as a standard, and all of these are available within the Flow API. And so the Java 9 Flow API contains the publisher, which is the Reactive Stream publisher. It's a data source that may have potentially unbounded stream of data. It does contain a subscriber, which is the receiver of the data. You have the subscription, which is going to be the context or the session between a publisher and a subscriber. And finally, you have a processor, which is going to be the stage between the publisher and the subscriber, which acts as both, and that is basically available as part of the so-called Reactive Stream API of Java. Well, I said almost nothing because the Reactive Stream API in Java 9 does have one small implementation. And keep in mind that this is just more of a test implementation, if I want to call it that way, for lack of better words. It is simply to illustrate the idea behind this particular API, which is the subscription publisher. I'm going to talk about this publisher and see how we can actually use this with a little example. So notice it's called the subscription publisher. The subscription publisher is an implementation, but the real interface you're after is the publisher interface. So how do we go about using this little example? Let's give it a try. So I'm going to start with the subscription publisher, and we will call this as publisher right now, is equal to new, let's say, subscription publisher right away. So we'll create this little subscription publisher, and that comes from the java.util.subscription publisher, as you can see. Well, in general, though, what you really want to use is the publisher interface, not the subscription publisher in reality. And you can see that that comes from the flow. The flow is just a class with a bunch of interfaces, one interface being the publisher interface available within that. Well, for now, let's go back here and simply change this as the subscription publisher, if you will. And once I create the publisher, what's the next thing I'm going to do? I'm going to go to the publisher and ask it to do a subscribe method on it. And I'm interested in subscribing to this particular publisher. I'll provide a handler to it. Now, I'm going to create a very silly little example to illustrate how this works. What is this handler that's going to be? Let's say this is going to be a new handler I'm going to create. We'll call this as, let's call it as my handler. So what am I going to do in this my handler? My handler is a class that I'm going to create right in here. And this class that I'm going to create within this particular class is simply going to handle this implementation of a subscriber. That's all I'm going to provide in here. So what does this really implement as an implementation? What am I really getting in here into this particular implementation? Well, all I'm going to do is to implement the subscriber interface. That's my real goal here. And once I implement the subscriber interface, my job here is to provide the various methods. Remember, we talked about the 3 channels of communication. Well, the 3 channels of communication are the data channel, the error channel, and of course, you also have the channel for the complete signal as well, or the 3 things that you're going to get out of this. That's what you want to really deal with. I'm having a little trouble here with the shortcut key, but for some reason, so let me try to move forward. So what it's going to do is to implement that particular interface. That's all I'm interested in, providing that implementation right here. So essentially, the idea is to go ahead and implement that interface. Let's see why this is not working. So all I'm trying to do here, all right, try again. Okay, so the subscriber interface, let's actually fire up the subscriber interface right here. And all this is providing is the onSubscribe method. This is a way to receive a subscription. This becomes very critical in a minute, you will see. And then on next is where you're going to get the data channel. On error is where the error channel comes in. On complete is where you can, receive a complete signal as it's going to happen when eventually it happens. Let's go ahead and give this a try. So let's go ahead and write the method over here. So we'll say public void on subscribe, and this method is going to be receiving a subscription like I talked about. This is going to be the subscription object I'm going to receive right here. So let's go ahead and provide the subscription method. And at this point, all I'm going to do is to save it away. That's all I'm going to do. So this dot subscription will say subscription is equal to the given subscription and save it away just for a later purpose. So that's going to be just a field where I'm going to store this away. And let's just say that's where I'm going to keep that. Well, I'm also interested in, of course, implementing the other interface methods as well. So let's go ahead and say on next. And the public void on next, what am I going to do? That's going to receive a piece of data. What kind of data am I really interested in? Maybe that's what I want to specify over here. This publisher, let's say, is going to be sending me let's say just the integer values. In fact, we'll do this right here. Let's say this is a subscription of integer values. So I'm going to receive some integer values as values being sent to me. And as a result, that's going to be a subscriber of integer that I'm interested in. And as a result, this is going to be an integer value that I'm going to receive. And all I'll do here is simply output the value is, we'll just print the value that we received so far. Then what I'm going to do, I'm going to provide the function which is the onError, and that's going to get a throwable. In case something were to go wrong, we'll just say error, and I'll simply output the error, really nothing exciting. And finally, the onComplete method. And in this case, of course, I'm not going to do anything. We'll simply say done. Other than that, there's nothing useful to do. So given this little example, all we are going to do is provide this implementation to run through and display the results of it. So we have the subscription, we have the onNext, we have the throwable, and we have the complete message to display right here. Okay, so far so good. But what is it complaining about? On subscription, this is going to be of integer as well. So that's the value that we're going to receive. Oh, what did I do wrong? This one here. All right, thank you. I love pair programming, as you can see right here. This is awesome. So just copy that. Like I said, my shortcut is messing with me for some reason here. There we go. Awesome. So now that we got that running, what's going to happen? I subscribe to it. But I need to, of course, start receiving some data, isn't it? So I'm going to say publisher. Well, this case, the interface itself doesn't have an emit method. That's not part of the interface to emit data. But what am I going to do here? I'm going to simply ask it to emit some data. And the way that I'm going to do here is to use a method which is called a submit method. And this is a little silly. I'm going to just submit a value of 1, and let's see what's going to happen. And I'm going to put a little sleep here, maybe a 10-second delay, just to give it a little chance to get through, and we will see what's going to happen when we run through this. So given this little example, this is more specific to how the subscription publisher is implemented. Remember, we talked about back pressure. Different implementations will deal with back pressure differently, whereas in this particular implementation, what they decided to do is that the back pressure is always baked in. So if you want to get the data, you need to tell how much data you want to actually receive. That is your responsibility. So to understand this, let's say for int I equal to 0, let's say I less than 10i++, and let's go ahead and just simply say publisher.submit right here, and we'll send the value of I right here as we run through it. Now, when I run this code, we're not going to really see much of a result at this point. And in fact, that's what I want to really show you here. When I run this code, you can see that it's running, but we don't see any output really at all. And the reason for that really is we haven't really communicated our back pressure needs to this particular application. So to fix that problem, what I'm going to do here is I'll go back to the subscription, and in the subscription, after I receive the subscription, I'll say this.subscription.request, and I'm going to say a 5. So this simply says, as a subscriber, I am able to handle 5 of your image. That's my capacity. So think of the request as your current capacity. So I'm saying I can handle 5 from you. Now, because I said I can handle 5, when I go back and run this little example over here, notice that in this case, it says 0, 1, 2, 3, and 4, and it sent us the 4 piece of data because we said that my capacity is 5, and that's what it just did. It sent us 5 data. Now, when I process a piece of data, what I can then do is I can say subscription.request, and I can ask for 1 more. Well, here's a way to think about it. Suppose I said I can take 5 pieces of data from you, and if you sent me 1 piece of data, you could send me 4 more at this time. So that means you have the ability to push 4 more before I have reached my capacity. Now, if I finish processing the data and I request for 1 more, now you can send me 5 pieces of data still. So in other words, think of this as cumulative. So I said you can send me 5, you sent me 1, you can send me 4 still. If I now tell you that I want to request 1 more, you can still send me 5. That's basically how this is going to work. So every time you send me 1, I'm going to say I can request 1 more. That means you can keep sending me a maximum of that capacity at the time, whatever that could be. And you can see that in this case, now I received all the data. Well, this is illustrating how the subscription publisher is working. You can dig into this a little bit deeper if you're interested in and take a look at what are the other things you can do with it. But essentially, the publisher, the subscriber, the Java 9 API is pretty much really geared towards being a standard. So the goal is not to provide an implementation for reactive programming. So what's the moral of the story? The moral of the story is, if you're keen about reactive programming, know that Java now has a standard, but in a way, think of it like a JDBC standard. You have an API description provided to you, and you can use that API description to rely upon a code as a standard to work with it. However, having said that, if you really want implementations, you have to look for third parties. As an example, let me show you a quick example here of maybe using a different implementation. Well, what kind of implementations can I use beyond this? Knowing that Java has a standard now, I can now use a third-party solution. For example, Akka is one good example of it. Akka is a Reactive Stream library written in Scala, but you can use it from Java as well. You have Reactor. You have so many other solutions as well. But one such solution is RxJava. RxJava created by the folks in oh gosh, I'm throwing a blank. What is it? Netflix, thank you. I should watch more Netflix, I guess. So in Netflix, and apparently they have a streaming problem to deal with, so absolutely, they open sourced the RxJava API. Let's give it a try. How does this really feel to use it? So I'm going to create a flowable.create over here. And within this flowable, I brought in the flowable and say emitter, and I'm going to simply call a method called emit and pass the emitter to it. What does the emit method really do at this point? My emit method is going to do the following right here. Let's make this emitter of integer as well, so we can emit some integer values from here. And what I'm going to do here is I'm going to start emitting data. Well, I did mention earlier that it's based on laziness, so I'm going to simply say starting to emit right here, if you will. And in this case, of course, I'm going to starting to emit from this particular emitter through this particular sequence of operations. Well, like I mentioned earlier, the way backpressures are dealt with is different between different APIs. So in the case of RxJava, I'm going to provide what's called a backpressure strategy. There are several strategies you can select for it. One of them is buffer. Buffer simply says, as this goes on, just start buffering the data. Another strategy could be a drop strategy, meaning throw away the data. It depends on the context of the application, whether backpressure makes sense to a buffer or a drop. Then I'm going to simply say, got a flowable, let's say, over here. And I'm going to store this away into a variable called, let's say, feed. So once I get the object, I say got flowable. But one of the things to keep in mind is the lazy evaluation I talked about. So when I run the code, notice it says got flowable, but it never actually bothered to do the starting to emit. And the reason is it's pretty lazy. Unless you start using it, it doesn't really do anything with it. Now that we created that, let's go a little further with this. Now I'm going to say .map, given a piece of data, I want to double the data. Well, it's still absolutely lazy, as you can see. It doesn't really budge at this point because it says, you haven't really made use of it, why should I bother? Okay, let's really make use of it now. Then I say subscribe, and in the case of subscribe, I've got the 3 channels I mentioned earlier. So I have the data channel where I'm going to output the data. I also have the error channel where I will output, let's say, over here, an error, and then we will simply say plus, and then we'll print the error out. And finally, the complete channel where we'll say output, in this case, done, and we'll display the data coming out of that as well, so we can display the details about it. And now that I've subscribed to it, let's go ahead and run the code and see what it does. And now you can see, because we subscribed, it says starting to emit. let's go a little forward and see how that's actually going to be used. So what I'm going to do here within this code is, I'll say count is equal to 0. Let's now go ahead and say that while count is less than 10, I'm going to go ahead and increment the count value. So we'll say count plus plus. And then I will say emitter.onNext, and we'll push the data to the receiver on the other side. And again, this is a silly example of pushing the count, but it could be any data that you're generating in your application. And then once I do this, I'm going to sleep for about a second in here and then continue right after this. So here is my little code to emit the data. Well, this is going to start emitting the data. So when I run the code, you can see that it's emitting the data 0, 1, and so on. Just to keep things a little easy for us, I'll just transform with the multiply 1, so it's easy for us to understand the output as well when we run this little example. So running this code, you can see it's emitting the data, as we can see, one step at a time. However, what I really want to do is to notice that it's emitting at a rate of 1 second. But what if my receiver is going to be a bit slow in receiving the data? So let's say this is emitting the data at about a half a second interval, but I'm receiving the data right here. We'll call it as process. And what does the process method really do? The process method says, I'm going to get the data, output the data, but I'm going to be very sleepy, and I'm going to sleep for about a second as I do it. Unfortunately, in this particular case, when I run the code, even though I'm generating data at a half a second interval, notice that it's printing at 1 second interval, and the reason for that is this is all completely synchronized with each other. But what you really want is asynchrony. So how do you get asynchrony into this? One way to do that is, that's pretty simple to do. You can simply say .observe on, and in this case, you can specify a schedulers dot. Well, I can say I'm maybe a computation thread or an I/O thread. I can decide that. Then I can specify in here the values for whatever I'm going to do in terms of the buffering that I'm interested in using. When I go back and run this little code now, what you're going to see here is that it's still printing at the half a second or 1 second interval, but I'm curious as to know how it's generating the data. So to do that, let's go back to this code, and we will output, let's say, emitting. And in this case, I'm going to simply say emitting plus, let's say, the count that we just emitted. Well, while we do this, let's also look at the strategy. Notice we said buffer over here. Well, now that we said buffer, let's wait for a little bit to get this through. So now let's go ahead and run this code and see what the output shows. And you can see that the emitting has gone ahead. It has already emitted 8 and 9 and 10, but this one is buffering and bringing it back, as you can see. So that buffering is built into it and works really naturally. On the other hand, if I go back here and say drop, well, this says if you're busy, don't bother, just throw away the data. Now when I go back and run this code, notice the emitting has moved forward. It has emitted 7 and 8 and 9. But if you look at the output, though, notice the output is actually dropping the data. We received a 1 and 2. We did not receive 3 and 4 because they were dropped. We got 5 and 6. We did not get 7 and 8. We got 9 and 10. The way drop works is this. If I am busy, you just keep throwing data out. And when I'm not busy, you send me the data. There are times when you don't want just the drop. There are times you may want really what is called the latest. So what is how is latest different from drop? So if I'm a publisher, if you're a subscriber, if you're busy right now, in the case of a drop, I'm going to just throw things away. And then when you're not busy, the next time I generate, I'll send the data to you. So you're busy right now, then I throw everything away. I'm not going to transmit right now, so I'm waiting. You are saying, hey, I'm ready. I'm like, okay, you're ready, but doesn't mean I'm going to do anything about it. I don't have anything to give to you until I get the data later. The latest, on the other hand, says, keep the latest value with you. So I'm going to send the data to you. You are busy right now. I generated data, I keep it. I generate the next data, I throw this and keep it. Generate one more data, throw it and keep it. And the minute you're not busy, I'm going to give you the latest right away because I kept the latest available for you. So in this example, I know it's a little hard for you to see in this example, but when I run this though, you can see that there's a 2 and a 4, and it's going to immediately give you the latest without any delay as soon as you are available and ready to use. Please.
But there was emitting 6, but the next number is 5.
Right. In this case, you're saying this one here? Yeah, because there's a time difference. They are asynchronous, right? So, one happens in one thread, the other happens in another thread. Did you throw the speaker to yourself when you asked the question? All right, so that's basically the idea, is that you have, asynchrony right there going towards this. So that's basically the idea behind this, is how you get this asynchrony. I want to mention, we saw the back pressure over here, how that's being used. So let's quickly see where we are. So we looked at the publishers, we looked at the subscribers. You can cancel the subscription as well. We talked about the back pressure. Let's talk about multiple subscribers to end this. This is one other very important distinction between the way reactive streams work from the Java 8 streams. In the Java 8 streams, you have one pipeline, that's all. You don't have really branches. You don't fork through and push the data into forks. That doesn't happen. On the other hand, in the case of reactive streams, you can actually have multiple subscribers, and that's really baked in. To understand this, let's change the example slightly to look at a different way of looking at this particular example. So to understand how this works, let's recreate this example this time, but I'm going to use something built in to make our life a little easier. So what I'm going to do here is to say flowable one more time, but I'll use an interval. So every second through it, I'm going to create a time unit dot seconds, not days, dot seconds, and we will create a little tick. Every tick will create a little data. And I'm going to then go ahead and subscribe to this. So we will go ahead and save this away as a feed, if you will. So that is my feed of data. Once I subscribe to the feed, I'll say feed.subscribe. And in this case, when you give me a data, I will call print it, and I'll say S1 colon, and then a plus, and I'll put the data and print it. Well, this is my first subscriber. So let's go ahead and write the print it method. And what does it do? It takes a message, and all it's going to do is print the message that it received. So given this, let's go ahead and add a sleep of, let's say, about 10 seconds right here. And let's continue with this code to receive this data and process it. Well, when I run this code, it's pretty obvious what it's going to do. It's going to generate the value for every tick, and we see this being displayed right here. Okay, so that worked really well, but what's going to happen if after, let's say, about a 5 seconds delay, I'm going to say feed.subscribe, given the data, print it, but this time it's going to be S2 colon plus data. So now we have two separate subscribers for the data, as you can see. So when you have these two subscribers coming in, what do these two subscribers actually see? Well, there's no good one right answer. It depends on what you really want. So in one hand, if somebody comes into this room right now to listen to this talk, they're going to just listen from where we are right now. They're going to start listening from the beginning. On the other hand, if somebody goes to YouTube to listen to the talk, they would start listening from the beginning. And you might be in the 15th minute of the talk, but you mention it to somebody, and they're going to start from the first minute. So there's no real answer, which is the right answer. And you can configure that. By default, this is going to start a new subscription. Remember the subscription we talked about earlier? You're going to get a new subscription at this point. So when I run this code, you can see that it actually starts with 0. At the end of 5 seconds, when S2 subscriber joins in, notice that's seeing 0 and 1 and so on. So that's a new subscription that it's actually working with. There are times, however, you don't want a new subscription. You want the other subscriber to join in on your current subscription. If that is your goal, what you can do is you can share your subscription by simply using a share, and then that becomes a common subscription shared by the multiple subscribers. So when I execute this little code right here, you can see that S1 started over here. At the end of 5 seconds, when S2 joins in, you can see that they both are actually seeing exactly the same content because they're sharing their subscription. Again, you couldn't do something like this with the Streams API because a Streams API is a single pipeline from the beginning to the end, whereas in the case of reactive streams, you can have multiple subscribers, and you get to decide how the subscribers are going to deal with the data, whether they share a subscription or whether subscriptions are independent of each other. That's a choice that you get to make depending on what you're trying to do. To summarize what we talked about, reactive programming has been around for quite a while now. However, the development has been done by multiple different organizations. They got together, put their head together, they came with a Reactive Streams API. Well, the question was, how does Java handle this? Good news now, Java has a standard. Pretty much the Reactive API became the standard in Java. If you want implementation, don't look for it in Java 9, look for it outside. But the good news is this is going to move forward as a standard for the Java community. And that's the good news, is that when you invest your effort into Reactive Streams API, you can be assured that there is a standard that we are going to be working towards moving forward. And as a result, the vendors have agreed to put their heads together. And so that's a good news for us, the developers. Hope that was useful. Thank you.